Dear student, myself Rajendra Aaseri, I am Assistant Professor in Computer Science Department at Government Bangad PG College, Didwana. In the previous lecture, we discussed about various concepts on database and management system, and we started a new topic on entity relationship diagram. In entity relationship diagram, we discussed about entities, representation of entity with the help of rectangle, weak entity, significance of weak entity, notation of weak entity with the help of double rectangle, then attributes representation with help of ellipse, types of attribute like simple attribute, composite attribute means which can be having some sub attribute like name can have some sub attribute like first name, middle name and last name, right? And then we discussed about some derived attribute, right? Derived attribute means which are derived from the some existing attribute, right? Then some mapping cardinality constraint we discussed, because in a relationship there can be involvement of the entity in either partial manner or full manner. So there are four type of classification we discussed already: mapping cardinality constraint, and in that we discussed about one to one, one to many relationship, many to one relationship and many to many. So all these we discussed in detail. Then we discussed about the conversion of the ER diagram into a relational schema and redundancy in the relational schema, right? Means whenever we are making a relation corresponding to entity set and corresponding to a relationship set, then some attribute are duplicate in entity relationship, entities relational schema, as well as in the relationship relation schema, right? Means table of the relationship or table of the relationship and table of the entity are having some common attribute which are redundant. Okay, so now in today's lecture some concept. So up to this design process, complication arises in the design process already done. In modeling we started about the ER model, then constraint, how to put a condition, how to make some condition visible or to check the condition in order to satisfy the database constraint. Then ER diagram, in ER diagram various notations. Then with banking scenario we discussed about the ER modeling. Then what are the various design issues that can occur and how to resolve them. Also we have discussed weak entity set, already we have done on this. Then in the extended ER feature we done about aggregation, specialization and generalization. In the bank database we discussed about 6 entities we have taken. Then in this we added specialization and generalization flavor also, and all these concept we discussed in banking scenario. Then reduction to relational schema done. Now in today's lecture some new concept. So first point is composite and multi-valued attribute. Okay, composite attribute are flattened out by creating a separate attribute for each composite attribute. So if we want to reduce the redundancy and if we want to simplify our composite attribute or multi-valued attribute in order to design a perfect database, then composite attribute can be flattened. How? By creating a separate attribute for each component attribute. Suppose I am saying that in the example, suppose given entity set customer with composite attribute name with component attribute, like component attribute means sub attribute first name and last name. The relational schema corresponding to the entity set has two attribute. First attribute will be name dot first name. Name is the main attribute, and if we will make these sub attribute also as the simple attribute, then how to do that? With the help of dot operator. And the main attribute is name, so name dot first name and name dot last name, right? Now a multi-valued attribute M of an entity E is represented by a separate schema. Okay, suppose if we want to represent multi-valued attribute, then how to represent? So we need to represent this entity E by a separate schema. How? Schema EM, okay, has attribute corresponding to the primary key of E and attribute corresponding to multi-valued attribute M. Okay, means entity relationship and schema for multi-valued attribute we need to separately define. So in the relation schema, EM has attribute corresponding to the primary key of E and an attribute corresponding to multi-valued attribute M, right? Example, suppose in multi-valued attribute, dependent name of employee is represented by a schema, employee dependent name, and it is represented as employee ID will be taken as the primary key and department name will be the some non-key attribute, right? Now each value of the multi-valued attribute maps to a separate tuple of the relation on schema EM. Example, an employee entity with primary key 123-45-6789 and dependent Jack and Jan maps to the tuple. How to map these? 123-45-6789. This is the primary key and the dependent are Jack and second will be same primary key comma Jan. So in this manner we can sort out the concept of the multi-valued attribute. Next is representing specialization via schema. So up to this point, we discussed the representation of the specialization concept in ER diagram. But now we are discussing that if we want to implement this specialization concept in design of the database, means in a relational schema or relational table, then how to do that? So there are two methods listed here. Method first, so step by step we are doing. First step, we need to form a schema for the higher level entity. Now you will have some question that what is higher level entity and lower level entity. So to introduce the concept of higher level and lower level already explained, but again I am reminding you that in case of aggregation, what we are doing in case of aggregation, it is a relationship between relationship. Aggregation arise why? Because we are having a relationship between relationship, and you all know that relationship can be possible between entities only. But if there is any relationship between the relationship, it means one relationship we need to make as an abstract entity. Okay, that is called as the higher level entity. Why higher level entity? Because according to the level of abstraction, if we are hiding more and more detail, it means level of abstraction will be keep on high for that particular entity. So in case of aggregation, the one relationship will be made as the higher level entity, right? Next, so we need to make a schema, separate schema for the higher level entity. Next is we need to form a schema for each low level entity set, because in low level there are a relationship, and all of you know that if there is a relationship, then there will be some entity set also. In ideal case, a relationship in lower level entity, in lower level relationship, there are minimum or exact two entities are involved, right? That is called as binary relationship. So we need to form a schema for each low level entity set, which include primary key of high level entity set and some local attribute. Clear? So some schema are listed here. See, first schema is schema and attribute table is given here. So schema name is person. In schema person, the attribute is name, street and city. Second schema is customer, name and credit rating. Third is employee, here name and salary, right? Now drawback, if we are representing in this manner, then what is the drawback? So drawback is getting information about an employee requires accessing two relations. the one corresponding to the low level schema and the one corresponding to the high level schema. Okay, so here we need to just indicate the relation for both the high level entity as well as the low level entity. Okay, so we need to get information about an employee which require accessing two relation. One is low level schema and another is high level schema. So the accessing time will be more and the query will be more complicated in this case. So there is some another method. If you want to represent specialization as schema, method 2 says we need to form a schema for each entity set with all local and inherited attribute. Like schema is person, so here we need to say name and street and city. This will be the attribute for person. Customer, name, street, city, and credit rating, 4 attribute. Employee, 3 attribute, name, street, city, and salary. There are 4 attribute corresponding to employee. So what we need to do here, we need to make a schema for each entity set of with all local and inherited attribute. So here it is not a concept of higher level entity and lower level entity, right? Now, if the specialization is total, the schema for generalized entity set, that is person, not required to store the information. Very important. Means if we say that specialization is total, then the schema for generalized entity set, that is person, does not require to store the information. Now it can be defined as a view relation containing union of specialization relation, right? Now, if you want to depict the explicit schema, then they may still be needed for foreign key constraint. Okay, in that case, foreign key constraint are required because there is a dependency in case of specialization. Now what will be some drawback in this method? So if you see, street and city may be stored redundantly. If you see street and city, so in person entity set, street and city is coming, and in customer also street and city is coming, in employee also street, city and is coming. In all the three entity set, these attributes are redundant. If redundant, it means it is loss. We can say just accessing time will be more. So street and city may be stored redundantly for people who are both customer and the employee. Clear? So if we say people is a, we are specializing people, and here I am writing is a specialization is a, it is a employee, it is a employee, or we can say it is a customer, right? So here from the people, street and city is coming in employee also as well as the customer. So data duplicacy or redundancy will be present in this case, in this method too. Next is schema corresponding to aggregation. So in order to understand this, first see the example. If you see in this example, there are employee, job, branch, and manager. 4 entities are there. If you see, works on is the relationship between employee and branch, job and branch, clear, and job it is relationship between works on and manages. Between works on manages, if you see, there is no entity. It means it is works on is also relationship and manages is also relationship. So relationship between relationship, it means it is a concept of aggregation, right? And generally in a database, this concept violating the database constraint, it means this situation means relationship between relationship we need to just resolve. It means what we need to do, we will make one relationship as a high level entity, and then this will be high level entity, another is manager. So first relationship, first entity, second entity is manager, and in between the relationship is manager. So by making the upper higher level relationship as the higher level entity, we can implement aggregation concept, right? So in this example, if you see, aggregation manages between relationship works on an entity set manager, right? It create a schema manages. For the managers we need to create a schema, and we will take employee ID from the employee relation, branch name from the branch relation, title from the job, and manager name from the manager relation. So from all these four we will take, and which which relation is taking the attribute from all four? The managers, because it is the main relationship, right? Next is schema works on. Now this internal high, in the high level entity, the relationship again existing, that is works on. So this works on schema is redundant provided we are willing to store null value for attribute manager name in relation on the schema manager. So in this manner we can implement relational schema corresponding to aggregation, right? Now UML is unified modeling language, and it is having some features, and it is correspond in ER diagram we are using some notation. Similarly in UML also we can use some notation, like here see, to represent the entity set and attribute we are using in ER diagram the rectangle and ellipse. This is for ER diagram. In case of UML diagram, unified modeling language, we need to write down a table. In this, the heading of the table will be relation name, that is customer, and in the next after the customer we need to write down all, list all the attribute, customer ID, name, street, city, all these things we need to enter, right? Next is relationship. To indicate the relationship in ER diagram we are using rectangle, diamond, rectangle, right? In this manner. But in case of UML diagram we need to write down the entities, then R for to indicate the relationship, then roles we need to indicate that entity is performing which type of role in that particular relationship, right? So similarly, we can present all the symbols in case of UML. Now UML, we are mainly using class diagram. Class diagram is nothing else. It is just used for the binary relationship that are represented in UML by just drawing a line connecting the entity set. Now the relationship set name is written adjacent to the line, and non-binary relationship drawn using diamonds, just as ER diagram in the ER diagram, right? So that's all from this lecture. Thank you.